There are three relating to flow of electricity. They are pressure or voltage, current intensity, and resistance. First, let us consider pressure. With nature always trying to maintain an electrical balance, there is a tendency for any negatively charged object to throw off or repel its excess of electrons, and for a positively charged object to attract electrons. This urge to maintain an electrical balance is potential electric energy. And since this potential energy is a repelling and attracting urge caused by opposite charges, its force or pressure is equal to the difference in the charges. It is called the difference in potential or potential difference. The unit of pressure or potential difference is the volt. The voltage, then, is always the potential difference at the negative and positive terminals of the source of the electric energy. It represents the difference between the number of extra electrons at the two terminals. And when a suitable path is provided, the potential difference causes the electrons or current to flow from one terminal through the conductor to the other terminal. To explain how this works, let's review the action of the atoms and their electrons in a piece of metal, where we saw swarms of electrons moving freely in all directions about the atom. Substances in which this takes place are good conductors of electricity. If an outside electric pressure or voltage is applied to a conductor, the electrons will move predominantly in one direction. The effect is that electrons move from the negative to the positive terminal. This is the electric current. The unit of electric current is the ampere. 1 amp, now hold on to your hat, 6,300,000,000,000,000,000 electrons passing any given point in 1 second. Current or amperage, then, is the number of electrons that pass a given point in a given time. And now the third factor, resistance. This factor is controlled by the nature of the material through which the electrons flow. Again, going back to the motion of electrons in a metal, we said that they moved freely about and among the atoms. However, even in the best of conductors, some of the electrons collide with the atoms, tending to retard the movement of the electrons. This is the cause of electric resistance. Collisions are more probable in some metals than in others. Therefore, different metals offer different degrees of resistance to the flow of electrons. For example, copper has low resistance. It permits the electrons to flow freely with few collisions and is therefore a good conductor. Iron offers more resistance than copper. Collisions with the atoms are more frequent. In some substances, no electrons are free to move around as in the metal. All of the electrons stay with their atoms so that no current can flow. These substances are the insulators: glass, porcelain, rubber, and many others. The collisions that the electrons have with the atoms set the atoms into more violent vibration. This makes the metal hotter. If there are enough of these collisions, the metal will radiate heat and light. Heat and light from electrical sources, then, can be obtained as the result of resistance in some metals. The unit of resistance is the ohm. Its value is best understood when its relation to the other factors is explained. A pressure of 1 volt produces a current of 1 ampere through a resistance of 1 ohm. Whatever the source or the magnitude of electric energy, these factors always have the same relation to each other. So, in order to supply our great demands for electric power, we must have facilities for generating great currents at sufficient pressures to overcome the resistance of the lines, as well as to do the work. Power for industry, transportation, and light, as well as for many other conveniences we use in our daily lives. Our own sources of current able to perform these amounts of work are the electromagnetic generators. In order to explain the manner in which electricity is produced by electromagnetic generators and used in most electrical machinery, let's have a look at magnets and magnetic fields. The Earth itself is a magnet. So are the tiny electrons. All of the electrons in any object are tiny magnets. When a predominant number of these tiny magnets point in one direction, we have an extremely small magnetized block called a magnetic domain. Magnetic material, that is, material capable of being magnetized, is made up of such domains, pointing in all directions. When these domains all point in the same direction, we have a magnet. In some materials, such as copper, the tiny magnets of the electrons never line up. These materials are non-magnetic, cannot be magnetized. Every magnet has a magnetic field. Magnets may be made in various shapes to provide convenient and strong fields. To understand how a magnetic field is useful in the generation or application of electricity, let's go back to the electron, Mr. Electron, and watch him move across the magnetic field. Will you do it again, Bud? Now notice, as he enters the magnetic field, he's deflected from his original course.
By the way, you guys share the same
Depends upon his velocity.
chemistry classes. Sorry, what?
Now, as we have previously shown, conductors have many free electrons.
God, I had it in my
And if a conductor is moved across a magnetic field, the mechanical action causes the electrons in the wire to be deflected, just as we saw in here the electrons deflected. This, in effect, establishes a negative and a positive charge at the ends of the conductor.
Bye.
We now have two charged terminals capable of producing a continuous flow of electric current, just as we had in the cell. This is accomplished in practice by...
Did you guys find it interesting?
Yes, yes. I didn't even know the
Jesus?
Earth was
Yes.
magnetic.
To me, I thought this was like really super interesting. And it explains a lot of stuff. It's a lot to take in, but it explains a lot. Anyway, thanks guys.
No, 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 no. Yo no quiero pegar.
Where you going?
Huh?
Where you going?
Over there.
Alright, I'll get some lunch.
Alright.
I just did my first my makeup lab thing. And on the message.
Take a shower?
Yeah, dude, every morning. Every morning. I was like, I'm going to let you like tell this to my
I'm good.
So this is the third time I'm doing work.
So you should buy them. And I'm pretty sure sometimes it feels like yeah, you're working on highway from